simplify. And I just got to be careful when I write them. X bar, Y bar, Z bar, plus X bar, Y bar Z, plus X bar, Y, Z, plus X, Y bar, Z, plus X, Y, Z. I picked this because there's a couple of things I'm going to do to it. I'm going to take the first group together. I'm going to just put parentheses around to let you know I'm going to be working with them. And the reason I chose the first two, because if you look at them, notice you have X bar, Y bar common to both of them. So if you factor that out, if you take it outside, what's left? Z bar plus Z. And what is Z bar plus Z? That's a 1. So this will simplify to X bar, Y bar. So I took this and right there. Now let me look at this. I can't take this and this because they're different by two things. See the X bar and the X and the Y and Y bar? So I can never combine these two, but I can take this and this. So let me group. And the last one, watch what I'm going to do. Isn't that what's left? But I'm going to group that with also X, Y, Z. So where are you getting the X, Y, Z?
You can use it twice.
Yep, you can write it twice. What's X, Y, Z or X, Y, Z? Isn't that still X, Y, Z? What's X or X? X. So what I did actually, I added an extra term, called it X, Y, Z, to match this. The reason I did that, that allows me to simplify this piece now. So when I look at this group here, this group, what do they have in common? Y, Z. What's left? X bar plus X, which will give me what? What's X bar plus X? 1, that's a YZ. And this group I can take out what? XZ. Y bar plus Y. Y bar plus Y is what? 1, that's XZ. And now you try to simplify more if you can. I can factor a Z out of these, but you have what? X plus Y doesn't really help me. Nothing here, nothing here. Okay. Now I was just thinking too, same problem. Instead of duplicating this, let me look at it again. Same problem. x bar, y bar, z bar, plus x bar, y bar, z. Group the first two. That's fine. I took this with the last one, right? And the only thing left is what? X, y bar, z, right? What about instead of adding x, y, z, what about if I add x bar, y bar, z bar? Because you can add any one of these terms, right, twice. So instead of adding that term, what about if I add this? Let's see what happens. So instead of adding x, y, z, I opted to add this term. You can write the term as many times as you want to, 5 times if you want to. Does that make the problem better? Let's see. Factor x bar, y bar. What's left? Z bar plus z. And that's a 1. Add here. What can we add? I mean factor out. YZ. What's left? That's YZ. And the last one, if I factor out, I can factor out what? Y bar z. X bar plus x, right? Which is what? Y bar z. Now look at the last two. See the last two here? If you factor a z out, what's left? Y plus y bar, and which is a 1. So basically in the lab, if you were to build the top one versus the bottom, so it depends really how you approach it. Sometimes by going different path, you might have a different answer to it. So the top one, if you were to build it in the lab, I have x going through a NOT gate to give me the x bar. I got y going through a NOT gate to give me y bar, and them together. I got x and y. And I got x and z. And they're all what? Or together. That's your sum of products. That's the top one. If you build the bottom, what are you going to have? The top gate stays the same. And the result is what? ORed with Z.
So you can come out with 2 different answers?
Sure. Yep.
Would there be any other way to simplify that top one? Is that
I can look at it and see what other combinations I might be able to do.
is it like it'd be like
Can I take this and this, right? And x bar.
No, I just mean the result.
You have to look at like other options if it's possible. So you really got to explore all the possibilities. Now the good news is we have other techniques that are going to come later. That one method, if you do it right, I don't care how you do it, your answer is going to be the same one, simplified completely. But the problem with this design here, it looks like this is a simpler design. The truth is probably not really, because you still need a chip for the AND gate, and it has how many on it?
3.
4, right? 4 2 inputs, if you remember last time. So if you're using 1 or 3, you still need that chip. You still need one for the OR gates, and you still need one for the NOT gates. So in terms of the number of chips, you're going to reduce that. What you reduce probably the connection to them. So the manpower, because people have to connect these, solder them, connect them. So you're eliminating that part. I don't have to connect all these extra wires. I can do with that. So time-wise, maybe, but not in terms of number of chips. Unless I decide to go with NAND gate or NOR gate, we didn't cover yet. That's coming up shortly. Because with NAND gate, I can probably do the whole design with one chip. Let's try another one. Here we go. A, B, C bar plus A, B bar, C plus A bar, B, C plus A, B, and C. By looking at this, I'll wait till you finish writing. If I took these two, could you simplify them? Yeah. Just these two. Notice you can factor A, B, right? And if I took these two, can you simplify them? Yeah. Yep. And if I took these two, could you simplify them? Yeah. Yeah. So what I'm going to do actually take the A, B, C and write that 3 times because that's what's equal to. I don't have just to write it once. Because I can simplify with every one of them, ABC or ABC or ABC, still ABC. But that allows me to group it this way. So by writing it 3 times, I can group it with this, with this, with that one. Now with these two, A, B, factor them outside, C bar plus C, which is a 1. These two, A and C, outside. B bar plus D, that's a 1. And these two, B and C, are outside. And I can go with that like this. AB plus AC plus BC. Everything we've been doing so far is called what? Sum of product. So what about if your expression is product of sums and you want to simplify it? That's a little bit more challenging. So this one now we take two AND gates, A and B, or 3 of them actually, A and C, and B and C. All of them together. And that's what that expression is. Four gates. Now let's take product of sum. Again, we've been doing sum of product. How about product of sums? So simplify. A plus B bar plus C times A plus B bar plus C bar times A bar plus B plus C times A bar plus B bar plus C. Now, let me remind you, we can derive that equation. We have a rule there. Might be rule 10 in the Boolean when you have the list of rules. Where are they? I think it was 10 or 11. Let me see. Where is it? Is it 10? Where'd you go, 10? I'll derive it because I don't know where it is in the book. A plus A bar B. Color them actually come in handy here. Let's see what that's equal to. Well, I'm saying that's equal to A plus A bar plus A plus B. Let's see why. So notice I can change, when you have something like this, I can change to make it look like this. So we'll see if that comes in handy here or not. Why can I do that? Because if you FOIL this one out, if we FOILed, what's A times A? A. What's A times B? AB. What's A bar times A?
1.
How about 0? That's an AND. And if it was O, it would be yes. A bar and A is 1 and 0 is 0. And this is what? A bar B. Now you can factor an A out of these two. What's left? 1 plus B plus A bar B. What's 1 plus B? 1. So if you have A plus A bar B, it's equal to A plus A bar times A plus B. And if it was backward, by the way, those come in handy a lot. If this was written backward, I'll derive it. Again, to derive it, FOIL this one. That's what? A bar plus A bar B 0 AB. Factor the A bar out. 1 plus B. 1 plus B is 1. So you might see me use these equations. Why am I interested in them? Because I'm looking at this here. If I'm looking at the top two, they remind me a lot of this one. Let's see why. Let's see why. Let's take this one, just the first two. And let me rewrite them. A plus B bar. I'm going to put group around them. Plus C times A plus B bar plus C bar. These two are the same. Watch what's going to happen if you FOIL them. Ready to FOIL them? Let's see. What's this times this? A plus B bar. What's this times this? A plus B bar times what? Times C bar, right? What about this? How about A plus B bar times what? C. And the last one, which is what? 0. And if I factor A plus B bar out, what's left? 1 plus C bar plus C. That's a 1. So notice when these guys, the same, and this is the complement of that. Notice how the complement? You're going to end up just with that term. So A plus B ANDed with A plus B bar, it's always going to be A. Or as a rule here, I'll just make it X, I'll avoid A and B because I'm using A and B. X plus Y and X plus Y bar. This will always simplify to X using the FOIL method. That's what we just did. My X in this example is A plus B. Well, if you look at the second part of the problem, look what you notice. You have A bar and you got C. So I can write the second part as A bar plus C plus B. That's the group together. A bar plus C plus B. And if I apply the same math, that should give me what? And. A bar and C, and not or. Yep. Maybe I should leave the upon the next line so you don't get confused. So the whole thing now becomes A plus B bar, and we say the other one is what? A bar plus C. And that's my answer. If I want to leave it in terms of product of sums, that's my answer. If I want to change it to a sum of product, they're probably going to tell you in some of them, we want the answer in product of sum, and some of them we want it in sum of product. So this is actually product of sums. So if they want the answer in product of sum, you're done. But if you want to change it to sum of product, for some reason they want to convert that to sum of product, then we use the FOIL method, right? If you FOIL this, what do you have? 0. This would be what? AC, A bar, B bar, B bar, C. So that would be AC plus A bar, B bar, plus B bar, C. And this is what? Sum of product. This is product of sum. This is sum of product. Usually when they have product of sum, they're probably going to ask for the answer as a product of sums. They want it like this, stop right here. Let's try another one. Let me take this example. Simplify. X bar plus Y bar plus Z bar x bar plus y plus z bar, and x bar plus y plus z.
Does the duplication rule apply?
Or still apply, sure. X and x still x. Notice I'm looking at it and I'm saying like this and this, I'll be okay, right? If I did this and this, and if I did this and this, I'll be okay. See them? Because you get the x bar and the y common to both them here, and if I did this and this, I get the x bar and the z bar common to both of them. So I'm going to repeat that term. So here, I'll just group them like this. And I'm going to put them in order there. I'm going to write this x bar plus z bar plus y bar. And I'm going to group the x bar plus z bar. And let me group it with that one. That's x bar plus z bar plus y. That's one group. I just decided to rewrite them differently, so x bar, z bar in the front. And the second group, I'm going to take this and this. So I'm duplicating that one. I'm saying since this will help me, let me add it to both sets. So that's really the one I'm adding, that term, because that allows me to simplify this and simplify this. So the second group, I'm going to take these two, and I'll take x bar plus y outside. Now these two are the same, and this is backward. You see I'm the opposite, the complement? That should give me what? X bar plus z bar. And this should give me what? X bar plus y. So this is my product of sums. Now, can I simplify this? Well, I can change it to sum of product if I want to. If I do a sum of product, I can FOIL it out. What's x bar and x bar? X bar y, x bar z, plus what? Y z bar. These, if you factor x bar out, I'm factoring x bar out, that leaves me with what? Y. And that would be what? X bar ANDed with anything is, with one or with anything, that's a 1. So it's x bar plus y z bar. And this is the sum of product. AND gate with an OR gate, 2 OR gates with one AND gate. Okay. Now the next block, I'm going to work the problem backward. Let's see, what does that mean? I'm going to give you the diagram and have you work it backward, give me the expression. I'm going to give you the diagram and have you work it backward, give me the expression. So here's the first one. D and E. C. C, D, E. So find the algebraic expressions for G. And that's the first question. Question 2, put it in sum of product form. So let's follow it and see what's going on. What do we have here? What's the output coming out of this gate? Out here. What is it? How about D plus E, right? That's an OR gate. Take that answer. This is C bar here, right? So what are you doing coming out of this? So C bar times D plus E. That's right here. This is C, this is D, this is E bar. What's the result here? C, D, E bar. And what is G is going to be? The OR of them. OR means addition, right? C, D, E bar plus C bar, D plus E. So that's the first one. Find the algebraic expression for G. We did. Done. Next part, we're saying we don't like that one. Can you put it in terms of sum of product? So it has to be all AND gates or together. Well, let's see. Well, I can what? Foil this one. And that will make it what? C bar D plus what? C bar E. Now let's look at this. These two here. Well, it's not duplicate, but you can factor a D out because you can simplify it. And what's left there? C bar plus C E bar. There's a rule about this one. Rule, I don't know what number. 9, 10, somewhere there. You just go back to the rules here. I have one actually on page 45, Rule 10A. It says A plus A bar B is equal to A plus B. And if you reverse it, if you go A bar plus AB, you can write that A bar plus B. Now, can I apply that here? Notice this one here looks just like this one. So I should be able to write that D times what? C bar plus E bar. Now distribute that one more time. C bar D, D E bar, C bar E. And now we got your sum of product completely simplified. Now let's make the circle a bit more complicated, a bit bigger. And here's my next circuit, the same thing. Find the expression for f here, then put it in sum of product. So I'll start with the end here, that's f. Coming out of f, up on the top, we have an AND gate. The AND gate has two inputs. One is C, one is A. The other input of an AND gate, this is ugly. That's another AND gate here, and that's B bar and A in the bottom. The top here, we have an OR gate. From this OR gate, there's two AND gates. One AND gate has C and D, the bottom one. The top one has C bar and another OR gate of A and B. I think that's it. I hope that's it. So find the algebraic expression for f, and part B again, put it in SOP form. Now wait till you finish drawing. The top one is the easy one. What's this gate here? AC. What's this gate, the output coming out of it? A plus B. What's the result here? So C bar times A plus B. What's this one here? What's this one? Add those CD plus C bar A plus B. And this one is what? AB bar. And right here is going to be what? The multiplication of these. So AB bar times CD plus C bar A plus B. So what's F equal to? Yep, AC plus AB bar CD plus C bar A, oh, C bar A plus B, right? And the next one, we're going to clean it now because they want it in sum of product. Sum of product. Well, let's simplify the inside one, see what will happen first. So that's part B now. It's going to equal to AC plus AB bar CD plus, this is what? AC bar plus what? BC bar. When you multiply the C bar through, yep, right there. Now let's distribute that. That will make it what? A, B bar, C, and D. A and A will give me an A, B bar, C, bar, right? And the last one, what's the last one? 0. It's an AND gate where you have B and B bar in it. If you look at the first two, you can factor out what? AC, what's left? 1 plus B bar D. And what's ORed with anything? Is that a 1?
Yeah.
The question, can I simplify this anymore?
Yeah.
I can take an A out. If you take an A, what's left? C plus what? C bar, B bar. This will be C plus B bar. Distribute that again because they want it in the form of sum of product. So basically this design that you see there, this whole design, can be replaced. The top gate stays the same. See the top one? The OR gate stays the same. But instead of having all these gates, all I need is one extra gate that has what? A and B bar. So all of these being replaced with this gate. Right there. The top one, A and C, stayed the same. See it? No change. This gate stayed the same, but all of these, 1, 2, 3, 4, 5, 6, being replaced with one gate. By the way, that when you are actually a product of sum, or if you're in sum of product, we call that the min terms. When you're product of sum, that's called max terms. So sometimes you have the word min terms, max terms, you know. Yep, we got time for one more. Let me change the look of the question now. Let's say I have a function that has three inputs, A, B, and C. And it has one output, F, we'll call it. And when 0, 0, 0, the result is 0. 0, 0, 1, the result is 1. 0, 1, 0, the result is 0. 0, 1, 1, that's a 1. 1, 0, 0, that's a 1. 1, 0, 1, that's a 0. And now we have 1, 1, 0, that's a 1. And finally 1, 1, 1. That's a 1. God, that's horrible the way I drew it there. It just didn't look nice. Graph paper will make it look nice. So same function, I just didn't like the way it looked because you can't tell which line is it. So I have three inputs, A, B, and C, and my output F. So if my inputs are 0, 0, 0, the result is 0. 0, 0, 1, the result is 1. 0, 1, 0, the result is 0. 0, 1, 1, that's a 1. 1, 0, 0, that's a 1. 1, 0, 1, that's a 0. 1, 1, 0, that's a 1. And 1, 1, 1, that's a 1. And the question here, just didn't like the way it looked there. The question here, we have multiple parts to it. The first one, show them in terms. So the minterms, there's one minterm. You're going to have a value of 1 when what? When A is 0, B is 0, and C is 1. So as a gate, this is what? A bar, B bar, C. When it's 0, you want to complement it to make it a 1. This one, A bar, B, and C. This one, A, B bar, C bar. This one, A, B, C bar, and the last one is what? A, B, and C. These are the when it says show the minterms, these are your minterms. Question number 2, show the algebraic expression. And sum of minterms. So we can write F here as what? A bar, B bar, C, plus A bar, B, C, plus A, B bar, C bar, plus A, B, C bar, plus A, B, C. Now, can we simplify that? Well, let's see. I'm looking at the first two, and they look good. What you have? You have A bar and C, right? If you factor A bar and C, what's left in the first two? Which is a 1, right? What else I can look at? Look at these two, right? You can factor what? A and C bar, what's left? B bar plus B. And that's the one that's AC bar. And what about the last two? I can take the last two again. I can use the ABC or this one twice. Right? Or I could take this with this. That'll give me BC. If I take this with this. If I take this and this, will give me what? AB. By the way, a lot of times instead of writing this expression the way you see it like this, people don't want to write that. So you might see F equals the summation, call them min terms, M for min terms. It has a value of 1 where? When it's 1, 3, 4, what else? 6 and 7, right? That's how they write it. You can have a summation of min terms, the summation of min terms at the value of 1, 3, 4, 5, and 7. Your job to figure 1 is 0, 0, 1. 3 is what? 0, 1, 1, A bar, B, C. 4 is 1, 0, 0, A, B bar, C bar, and so forth. What time is it? I'll practice more with this notation next time. I'll put a little flag here to remind me to practice. I'm actually one of the people who write the expressions like this because I don't want to write this. I make mistakes with them, the bar, no bar. So when I test, I put them in that format. So question 14, Q14. So I'll do that next time. Practice with this look. Very popular look there.